Hello everybody. Today we're going to be doing a package unit. We've got a package unit that we're looking at today. Is a heat pump package unit installed less than a year ago. We're just doing our preventative maintenance, making sure everything's still doing okay. Alright, so I tried using my wireless mic. This one, nope, that's not it. That's the receiver and wireless mic. Found on the both on TikTok shop and what's it called, the flip shop. The only downside is that for some reason it's not connecting to my phone and I don't know how. So if anyone knows how to set up the camera mic or the microphone that's used for recording videos and stuff, iPhone it just happened automatically, but for some reason Android it's not working properly and I don't know why. So the mic is charged and everything, I don't know. Anyway, we're gonna start by opening the unit up, cleaning the outside as best as we can, and then taking all the panels off to inspect everything. So we're also going to be checking the motor itself. It is only like 6 months old, so I'm not too concerned about it. But looks like there was lubrication jelly of some sort on top, or used to put the shaft down, so that's probably going to cause some issues later on down the road, but for today we're not concerned about it. So we've got some, I'll take you off real quick. So we've got some buildup of pine needles, dirt, all that kind of stuff. So I'm going to put some gloves on and get all that cleaned out, and yeah, we'll get all that cleaned out and call it a day. I don't know if you guys can see it, but that's a deer. Oh, I want to zoom in. There we go. That's a deer. He's just hanging out, minding his own business. All right, so got my gloves, got my audience, the deer. So yeah, we're just gonna clean everything out and go from there. See? Bye-bye. That is eventually going to cause drainage issues later on down the road, a few years from now. Could be next month, whichever. Or this fall, really. It's probably the biggest time for that. But it's going to cause drainage issues in that area when the coil sweats. We want to make sure that that's not going to be an issue. So now we wash her. Okie dokie, that's all she wrote. Now we're going to remove all the panels. So I have to go get my drill and then open up all the side panels and go from there. All right, so we've got all panels open. We got your main control section up there. That's where your heat strips are at. Since this is a heat pump, utilizes electric heat as backup. So I gotta go in there and double check which ones, but. And then that's your blower motor. It's a variable speed ECM, so there's no capacitor here. So there's just these electrical settings to check. Which in this case is going to be black and red, either black, red, or blue. That capacitor is for the compressor, so we need to check that. There's your compressor. So, and then obviously that's your condenser fan motor. So yeah, we want to make sure that everything is nice and snuff. All right, so I'm gonna restore power. Probably go back inside and double check the thermostat because it usually runs, it's a T10, so it runs on power from the unit. The fact that I turned it off means that there's no power, which means I probably have to reset it to cooling. So we're gonna go do that, but I'm gonna restore power first. All right, so you're a little bit lower now, which is good, but we're gonna be checking the compressor, the fan, capacitor, pretty much everything else that we need to check. So we're gonna start with the compressor, and yeah. All right, so we're gonna be checking the compressor power wires, which are in this case orange, red, and black. And they're zip tied to the side here. So as we're checking everything, I'm gonna be taking pictures for the form that we fill out. So I got orange, which I believe is the compressor wire. Oh, I got red too, but that's all right. Okay, so we got 5.4, 5.49, 5.5. We got red, which is here, 5.6. And we've got black, which is 4.5. And then if we look at the capacitor, looks like orange is the one, which I don't know. Yeah, you can kind of see it a little bit. Reposition you for a second. So you can see on the top of this capacitor, we've got a brown wire here, a purple wire here, a red wire here, and an orange wire here. The red wire is for the common from the compressor, or sorry, the run, right? So we're going to consider it a common. You've got your orange wire, which is your start wire for your compressor. Your purple is for your fan, your brown is for your fan. So when we go to do the voltage to test the capacitor, we're going to be checking the orange and the brown for the amp draws, which it's tough to get in here. So luckily with package units, we've got wires over here. I'll reposition you again. We've got wires over here that assist with that job. So these are gonna get a little wet, that's okay. We've got, I'm going to assume these three wires. So we got purple. Actually, we're gonna go with brown because we know that's up for the capacitor. So brown is 0.6. Then we got purple. Purple is 0.65. And then we gotta pick between three blacks. But I'm gonna go with this one. If it reads about the same, then we're good. And I got 0 and 0, which means this, by theory of elimination, oh, that's not right either. And we're gonna do this one. So I know that this is for the fan motor. There we go. All right, so we got 0.77, right? So that's for the amp draws of everything. So now we're gonna take the voltages of the capacitor. That way we can do that equation that I've talked about in the past and figure out whether or not the capacitor is good. Then we're gonna put all the panels back, go inside, do a temperature split, and check from there. Obviously, before we do that, we need to check the, you guys can see it's starting to ice up, which is good. That means that it's starting to get cold, which that's gonna give me a good indication for how well the unit is going to run with my temperature checks later. Okay, so I've got the meter down here in volts, and I'll read it out loud since you guys can't really see it. But we're gonna go where this red wire and this orange wire are. We're gonna take the voltage. My head's gonna get in the way, just so I can see. We get the voltage 367. And then we're going to do the exact same thing. This where this red wire's at and then where this brown wire's at. That's for the fan. We're looking at 325. Sometimes there's no contactors in here, but in this case there is, and it's hiding all the way back here. So we're just gonna verify. Obviously it's getting a call for cooling. So there is 24 volts. I mean, we do still want to check to see exactly how much, but high voltage we're looking at 242.7, and going in, how much is coming out? 242.8. That's fine. That's not a voltage drop at all. If anything, that's a gain. And then we're gonna check the low voltage is 26. So we are all good. Okay, so units put back together. We're going to rinse it off one final time, even though it's running. And then we're gonna go take some temperature splits in like 5 minutes or so. All right, so I was able to put the temperature probes inside. I do have a feeling that it's not gonna matter because I think the reversing valve is programmed wrong for this thing. Could be wrong, I don't know, but we'll find out. It seemed like it was relatively warm air coming out, so who knows? Which would be off-putting because the suction line was starting to ice up. You guys saw, or frost up. So, but I did do a little marketing for Apollo. Put stickers on. I said that today. I did the maintenance warranty. This is covered for 2-year labor warranty. 2-year labor warranty, 5-year, 10-year parts through American Standard. And then I put my business card on there, so if he has any questions, he can come out here, take a look, say, oh, I need Ty, and email me. So but I'm gonna kind of clean up the unit a little bit better, make it look a little bit nicer, and then we're going to go back inside and do temp checks. And then I'm also gonna go over the information with you here in a second. All right, so we're gonna kind of clean this up, make it look a little bit nicer. So you guys can see the nameplate is kind of off to the side. So like I said, I got my stickers and stuff. They're obviously gonna get wet, but it's more of the thought that counts in the presentation. So we're gonna kind of clean this up, wipe it down a little bit better, spin this around so we can get behind it as well. And what we're gonna do, the reason why this happened was because the back broke off. There's a little pin back here that kind of just clips in there. So what we're gonna end up doing is we're gonna be taking some of this Pookie tape and we're going to kind of wrap it around on itself like this, and then we're gonna place it more towards the inside here because of how big this is, and cover the hole so we know that it's definitely gonna hit because that's where the pin goes. And then we're just gonna use our best judgment with our eye. We're gonna push. It's not gonna guarantee, I can't guarantee it's gonna last forever, and I know it's not gonna last forever, but definitely looks better up and flat rather than halfway off, making a 6-month-old unit look like crap essentially. Yeah, so just checked the temperatures inside, and it was actually 10 degrees warmer going out of the supply register than in the return. So I'm thinking that I doubt that there's a refrigerant leak because it's a package unit and it doesn't happen very often. It can, but it doesn't happen very often. Or like a lack of refrigerant or something like that. But I'm thinking the reversing valve was just bad. Or not bad, but like programmed wrong. So I switched it over. I'm gonna run, as soon as that unit turns on, I'm gonna run it for another 15 minutes and see if it's actually cold air coming out. If it's not, then we could have some actual issues and we'd have to diagnose it some more and whatnot. So, but we'll figure it out. All right, so we are pretty much done. We're waiting for the reversing valve to finally go through its whole thing. The unit kicked on, so we gotta wait another 15 to 20 minutes. But I'm gonna go through the calculations for the capacitor and we'll see where we're at, see if we need to replace it. Okay, so I want you to go through this with me. So I'm covering up all of the math that I've done. But we have a 40/5, so that's for the compressor. That's 40 microfarads. That's 5 microfarads for the fan. Plus or minus 10%, which gives us 36 to 44 is the tolerance range, and 4.5 to 5.5 is tolerance range. Right? So we're going to scroll down. Compressor, I'll do one at a time. We have 5.5 amps on that orange wire. Multiply that by 2652. I know I have said 2654 in the past. That was wrong, so my apologies. Divide that by the voltage we found, which was 367.1. We got 39.73 MFD. That is within that tolerance range. So compressor side of the capacitor is fine. Moving down to the fan, 0.61 amps times 2652 divided by 325.5 volts equals 4.96 microfarads. That obviously is also within the tolerance range, so that capacitor is fine. Moving down to the contactor, there was no voltage drop. Compressor was set for 14.1 amps. Highest we got was 5.6. Fan motor was 0.85. The highest we got was 0.77. Blower was 3.9, and we were all good there. So with that being said, everything looks pretty good. So with the equipment being installed only 6 months ago, there's not much that we can do when it comes to obviously charging the customer or anything, because it's a 6-month-old system. So which that's fine, but we are still just waiting on that system to run for at least 10-15 minutes, and we'll call it a day. All right, so I was a little confused on why it was 10 degrees warmer. I came out to the unit and found out that because the heat strips were kicking on at the same time for cooling. It wasn't a reversing valve issue, it was a low voltage wiring issue. So I got that all fixed and squared away. The unit's running now. I have it in test mode, so I'm not adjusting temperatures. It's just gonna run until I stop it. And the heat strips are not kicked on, so which is a good thing. So I'm gonna put everything back together out here, have the conversation with the homeowner about everything, and then take some temperature readings at the very end, and then skedaddle.